This is section 4.2, polynomial functions and models. And we have talked about the vertex of a polynomial. We've talked about max and min. We're going to bring in some new terminology. This turning point occurs whenever the graph of a polynomial changes from increasing to decreasing or decreasing to increasing. So let's think about that. If you're going along and you're increasing, and you reach some point where you're going to change and now you're going to decrease, that is the turning point. Okay? And what else is it? This happens to be a max. If you were going from decrease, and you meet a point where it's going to change and you start increasing, that is your turning point, and it's also a min. All right, so it's just some new words for something that we've already talked about. And we are going to look at a few different kinds of functions, so we're just going to go over that right now. A constant function looks like this: f of x equals a, or f of x equals a number. And if the number is greater than 0, it's going to be above the x-axis as a horizontal line. No x-intercepts. And if it's less than 0, it'll be down below. Linear functions: f of x equals ax plus b. All right, if this a is positive, you'll have something with a positive slope, one x-intercept, no turning points. If a is negative, you'll have that negative slope. It'll be falling, one x-intercept, and still no turning points. When you get to quadratics is when we begin to have some turning points. If a is positive, you can have this or this. If a is negative, you're going to have it upside down. Now in this one we have no x-intercepts, but we do have one turning point. In this particular case, we have one x-intercept and one turning point. Now, we also could have had, didn't get this picture, I don't think, yeah, I didn't have another picture, but we could have had this, where you have one turning point and two x-intercepts. So just be aware, you could have up to two x-intercepts and one turning point. All right, and this one was the negative. All right, cubic. So this is the general form. It looks like a drain pipe. It can look totally, like this, like this, like this. How many x-intercepts do we have here? We have 3. And how many turning points? We have one right here and one right here. In this one, we have one x-intercept, and it looks like it's touching a bunch of places, but it's really just touching right there, and it's really no turning points. It's always increasing. In this one was when a was negative. When a is positive, we've got, in this one, we've got 2 x-intercepts and 2 turning points. Okay. All right. Quartic, that's 4th degree. All right. So in this one, we've got 4 x-intercepts, 1, 2, 3, 4, and 3 turning points. 1, 2, 3. 2 x-intercepts and 1 turning point, because we're increasing. We don't start changing to decrease till right there. 3 x-intercepts and 3 turning points here, here, and here. So, and we could go on to the 5th degree and 6th degree, but here's what we should get from this. The graph of any polynomial function of degree n, where n is greater than or equal to 1, has at most n x-intercepts and n minus 1 turning points. That's at most. So think about it. When we have a 4th degree, the most turning points we can have is 3. 4 minus 1 is 3. You could have less, but you can't have more than 3. For third degree, we can have no turning points, 2, 2. We can't have more than 2 because 3 minus 1 is 2. For the second degree, we can only have one turning point. So that rule is what we get from looking at those. That's kind of important. All right. Now we have some ideas about end behavior of polynomial functions. Your calculator you're going to use a lot, but sometimes when you put it in your calculator and you just do a graph, you're only going to get, say, one part of this. And you might think that's the whole graph, but you need to remember that there's always going to be some end behavior, and you can predict that. Even degree. So an n equals 2, 4, 6, 8. If a is positive, it's going to go up on both ends. Not sure what it'll do in the middle, but it's going to go up on the ends. If a is negative, it's going to go down on both ends. Odd degree, 3, 5, 7. If a is positive, it goes down on the left, up on the right. If a is negative, it goes up on the left, down on the right. All right, so that could be helpful for you to just have that chart to refer to. Piecewise function is literally something made up of pieces. So here's the whole function in this example. F of x equals x cubed if x is less than 1, and x squared minus 1 if x is greater than or equal to 1. So you got a first piece, you got a second piece. This whole thing is the piece. Well, actually, this is the graph. This is the piece of the graph, and this is the piece of the graph. And these are the parameters. All right, so let's look at what we've got here. So x cubed looks like that, but it says for x is less than 1. Well, here's x equals 1. So it's just this part of the graph right here. That blue part is where x is less than 1. The second piece, x squared minus 1, if x is greater than or equal to 1. So here's 1. We have a closed-in circle because of that equals, and it's just this piece because it's everything beyond 1. So when you put those pieces together, so now we have these put together, and we have this piece here and this piece here. One has an open circle, one has a closed circle, and it's discontinuous at x equals 1, meaning it breaks, it's not connected there. So it's not a continuous graph, and it is made up of those two pieces. Okay. All right, let's go look at some problems and see what we can do. All right, in this one, let's make this just a little bit bigger so you can see this. The x-intercepts are, and on your computer you'll be able to look at it definitely a little bit bigger, but I think we can actually see them. 1, 2, 3, 4, 5. All right, so the x-intercepts are at -5, 0, and 5. Determine whether the leading coefficient is positive or negative. All right, look at this graph. This is doing this, going up on both ends. If we go back to our notes, oops, I was going the wrong direction. All right, look at here, up on both ends. Even degree, A is positive. So that would be our choice. So you can refer back to that chart. And the minimum degree. All right, we learned that rule. Let's look back there. That if the degree is n, it has at most n minus 1 turning points. Well, we're trying to find the degree, and we have the turning points. So let's look back here. How many turning points do we have? We have 1, 2, 3 turning points. So we add 1 to get the degree. We're going backwards. Going backwards. So the degree, the minimum degree, is 4. All right, so that's how you use those charts. I'll make this a little bigger. All right, so we have this function, -4 minus 4x minus x squared, and we're supposed to do all of these things. So first thing is to identify the graph, and you could put it in your calculator, and you could check it that way, but let's think about something. We know this is quadratic, second degree, so we could eliminate this one and this one. Those are not quadratics. They're not a parabola. We also should notice this is a negative x squared, so that means it's going upside down. That means we could eliminate that one. So our choice will be here under B. So you want to use that idea of eliminating what you know to not be the case in order to help you sometimes. All right. B says identify the turning points. And so let's look here. What do we have? That is at -1, -2, and 0. So we want to look for that, and here we go. It would be that one. C part, estimate the x-intercepts. Well, we already said the turning point was here, and it's on the x-axis, so that should be -2 right here. All right. Estimate any local maxima. Local maxima. Let's look here. All right. Local maxima. That means the y value of the turning point. So that will be what? 0. So 0 should be the next thing. Okay. Local minima. So that's a min. Let's look back. Does this have a min? No, that thing's going on forever on both of those parts. So let's make this a little bit bigger. I guess I can't do that. Sorry. Maybe. Nope. I kind of messed up. Okay. All right, local min. No local min. That'll be there. And then the last part that we were doing said to estimate any absolute extrema. All right. So absolute maxima. So that highest point was what? At a 0. Did I cover up some of this? I think I did. Let's see. All right, I think I fixed that so that looks okay now. Estimate any absolute maxima. And remember that is the y value. And I think that was 0. All right, so we'll go back in and put 0 for that. And then any absolute minima, and we said there were none. So we've done everything for number 2. All right, number 3. Let's give ourselves a little room here. All right, oh, didn't want to do that. Graph the polynomial in the standard viewing window. So let's go in here and graph this function. Clear what's in there. 0.0234 x to the 4th, all right, minus 0.7488 x squared minus 2. All right, so let's graph that. All right, and it wants to know the turning points and put them in as ordered pairs. So how many turning points do we have? we have 3. Okay, so let's see if I can put this here. Not sure where it put that. Oh goodness. Okay, so I finally got that over there and got that fixed. Sorry about that. So we are trying to find this point, and this point as ordered pairs right here. So you want to realize that that's a min, that's a max, that's a min. So we'll go back in here, second calc. We'll choose min, and we're right here, so we want to move till we are to the left of that minimum point where we can really see it. Okay, that's good. Enter. And then we need to move back around till we're at the right of it and hit enter, and enter a third time. We get -4, a lot of zeros, so we're going to call that -4. -7.999, whatever, we're going to round to -8. So we've got -4, -8. That's one of them. So put whole numbers in this kind of question. All right, let's go ahead and find this max. Second calc. Max is number 4, and we'll be to the left. Whoops. Move up till we're a little closer. All right, we're to the left of that, so we'll hit enter. We'll go around and hit enter, and hit enter one more time. And this is really interesting. Let me see if I can pull this picture here. All right, I want to. All right, this number that you get right here, note it is it is 1.0256 e to the -6. That means you've got to the left of the decimal 6 zeros. You need to move that, you need to move that decimal 6 places. So you would actually have point and then 6 zeros, or 6 places, so 5 zeros and 1. So essentially you've got 0.0000, it's essentially 0, and you can tell you're at x equals 0. Sometimes the calculator does this. Don't let that confuse you. That is 0. When you see this kind of number, and many of you may get a question like that and your numbers here may be different, but as long as you've got e to a negative number, it's pushing a lot of places to the left, so it's going to be 0. So this one is 0, -2. And then if we did this one again, we would get a min of 4, -8. It does say to use a comma to separate your answers. So we've got commas in here between the ordered pair numbers. We need a comma there, or it will not count it wrong. It will not count it right. All right, so now it says a local min occurs at x equals. Local min occurs at x equals -4 and +4. The local max occurs at x equals 0. All right. Let's look at this one. Let me give myself a little bit more room. I'm going to make that a little bigger. All right, sketch a graph of f. And we want to do this in the calculator. Now, to do this in the calculator, you're going to have to do a couple of things. So let's write some things out before we actually go to the calculator. When we go to y1, we want to make sure we are in dot mode. And in y2, we want to be in dot mode. I'll show you how to do that, but you want to be in that. Then you're going to put each of these parts in parentheses. So So you're going to have parentheses x squared minus 1, close. You're going to open parentheses, and we're going to break this compound inequality into two pieces. So we'll have negative 2 is less than or equal to x, close, open. Now we'll have the last part, x is less than 0. On y2, we'll have 1 minus x squared, close, 0 less than or equal to x less than or equal to 2. All right, so we've got to put it in exactly like that if we want it to work. Now you will find the inequality signs, because we haven't used those really on our calculator, under second math. Okay, all right, so let's go to our calculator and put it in and see if we can get a picture that matches. All right, first of all, to change the kind of line, we want dot mode. Let's move over till you are on this line that's flashing, and you hit enter 6 times. 1, 2, 3, 4, 5, 6. Should be little dots like that. All right. Okay, so I'm going to open, put x squared minus 1, close, open, negative 2, and remember to use the little baby negative because it's the sign of a number, negative 2. Now I need less than or equal. Second math. Less than or equal is number 6. X, close, open, x, second math. Less than is number 5. 0, close. All right, let's go down to y2. Let's make that be dot mode. All right, let's go back here. All right, and I'm gonna delete that thing. And we've got parentheses 1 minus x squared, close, open, 0, second math. 6 is less than or equal to x, close, open, x is less than or equal to 2, close. All right, let's hit graph. Now, we're not seeing the same kind of picture because we don't have a window that matches. If you'll note, these are 6s, these are 4s. So let's change our window to match. So our x min is negative 4, x max is 4, y min is negative 6, and y max is 6. Let's see what we get now. All right, so let's see if looking at these 4, we can find the one that we believe it is here. Now, the only thing that's not going to show up on your calculator is the open circle and closed circle. Look here, if x is between 0 and 2, between 0 and 2, it has the equals, which means that will have a closed circle. If x is between 0 and negative 2, that's this piece, it's going to have the open circle. So if you were having to sketch this yourself, you would have to take note of that. But this is the one that matches. All right. Is this continuous? Look, it breaks at x equals 0. So it is not continuous. And we're supposed to solve for f of x equals 0. What are the x-intercepts? That's what we're looking for. And we can see there's an x-intercept there, and there's an x-intercept there. So it should be negative 1 and 1. All right. And the last question we have is another piecewise function, and it has 3 pieces. We need to make sure that we do our window this way, or you definitely will not get the right picture. So let's go ahead and put that one in. So here we've got the number 36, so put it in parentheses, close, and we've got an open, x is less than -6. And be sure you use the baby negative, otherwise you'll have a problem. All right, so that's y1. We'll come down to y2, and we've got in parentheses x squared, close. Now we've got a compound inequality, so we have to break this thing into 2 pieces like we did in that other one. -6 less than or equal to, so that'll be 6, x, close, open, x is less than or equal to 6, close. All right, come down to y3. Now I have to fix the dot mode on this one. All right, and we'll come over here, and we've got parentheses 42 minus x, close, and open, x is greater than, just 3, 6, close. All right, so we'll make sure, so the 2 places you have to be careful, that's a baby negative there, that's a baby negative there. So be careful of that. Let's hit graph. All right, that definitely does not match anything that I've got. It seems like I'm getting parts of something. Remember, we have to change the window. So let's go to our window, and our x-min is -30. Our x-max is 30. I think the scale is 5 on this one. And you could probably get it if you didn't do the scale, but let's try that. All right, y-min is -60, and y-max is at 60, and the scale is probably 10, 20, 30, 40, yeah. So this y scale is 10. All right, let's see if we get a better picture then. Okay, so which one is that going to match? Right here. Okay, so this is D. This is our picture. And the question says, is it continuous? And yes, there's no breaks. It actually connected everywhere. So this one is continuous. And so that's the 5 problems for this section. Not a lot, but there's a lot of little things. It takes a little bit of time to do some of those calculator questions. So that should get you through for 2.